Okay, the control panel via the communication cable is connected to the RTD probe. The control panel also connects the VFD wires to the mixer or the rake motors. Now, the reason why I'm centering on the mixer or rake motors because these are the only two motors that are physically attached to the vessel itself. And notice that the mixer motor is grounded, the RTD probe is grounded, which the tank is grounded, to the main power panel, which is grounded, and the control panel, which is grounded, forming one complete grounding situation back to the main power. This is where the problem is. The problem is the fact that the mixer and rake motors are actually attached to the vessel. Now, if you remember from your old grade school science project, if you take a wire and you wrap it around a piece of metal like this, and you apply power with a little battery, to this little wire, this piece of metal becomes a magnet. Now, when you're using a regular motor starter, like on the hot liquor tank, when you turn it on, the power flows to the motor with a really nice sine wave like that, really nice and smoothly. But when the VFD is turned on, the power goes to the motor like this. It's a really crazy wave like that. And because of that, of course, these are wires, a piece of metal, if you will, from the VFD to the motor, and this crazy waveform turns this wire into a magnet. So because that electrical field turns into a magnet, magnetizing this wire, this motor, and this, believe it or not, this tank as well. It's a very slight magnet. It's stainless steel, so you can't actually tell if it's magnetized, but it's a magnetic field. It's transmitting through these ground wires and coming back to the main, coming back to the control panel, and slightly, adding a little bit of interference, because this puts out a voltage, and the voltage has to come back from this temperature probe, and this little interference just kind of slightly messes up the signal wire. It starts to fluctuate back and forth here, back to the control panel. That's what you're seeing, and that's why you're seeing a fluctuation. So the $64,000 question is, and that's what it might cost, is how do we fix it? The short answer is, you can't fix it. You're always going to have some kind of interference. I talked to Control Tech at the show, the brewery show in San Diego, extensively about this, and they confirmed exactly what I was seeing in the panel in Escondido, that an interference is absolutely 100% going to happen. And even in Escondido, we did minimize the interference within a few points up and down, but we had the interference just the same. The interference is always going to be there, depending on the power system at the particular job site, whether the power is clean, whether it's filtered, whatever the situation is, it's going to dramatically affect what we see as far as the level and magnitude of interference. Now, even if we have a separate panel that has the PLC and the HMI touch panel on one of it, and just plug that into 110 volts, and we have a VFD power panel that has the high voltage in it connecting to the motors up to here, we're still going to have the same issue, and this is the same issue that Control Tech is having. They still have interference, even if you isolate them this far, because that common ground, that grounding that's necessary, always leads back to the panel, because there's a ground in this panel, and there's a ground in the HMI, and there's a ground in the main power panel feed. So no matter even if we isolate these two panels, the fact that there is a common ground wire that connects everything is the issue. Now, can we fix it? Can we get around it? Yes, we can. Now I see why a lot of the companies have the separate heater controllers. Even Shimo does. I don't think Shimo has a touch panel yet. I'm not sure, but correct me if I'm wrong. Or if they have one, they haven't had any success with it really minimizing the interference. If they have, then buy it and send it to them, and God bless them. But with this, that's why I'm proposing using the Honeywell heater controller, because it's a completely isolated system that doesn't use RTDs. It uses a matched sensor. A sensor that was made for this particular heater controller. Okay, most of the heater controllers that you buy are just a heater controller, and then you've got to buy a sensor, and you can buy various sensors or thermocouples and put them here. I'm proposing to use a matched heater controller. Yes, we don't have the fancy touch panel controls and all that kind of good stuff, but we've got a Honeywell T775 controller, the ones that you bought and are having shipped to me. Those are bulletproof because I've been using those inside of control panels with VFDs for over 15 years. with no interference issues, because they've got a sensor that was 100% matched to the heater controller, and they use what's called a thermistor. It's a totally different type. It's not a thermocouple. It is not an RTD. It's a thermistor, and this thing you can run the sensor out 1,000 feet without shielding or grounding cables. So that's what I'm proposing. I'm proposing just mount these to the face of the existing control panel that's there, wire it up, and that's your heater control completely 100%. And then you can run VFDs all day and night. You're never going to see interference. You're never going to see not even a hundredth of a percentage point of interference on the heater application. Now there is one thing I'm 100% confident that could eliminate the problem totally, and it's something we already talked about. DC motors and DC drives. Because the DC line is a flat line. There is no alternating current at all. There's no magnetic field, and you're going to get zero interference. That's why I proposed that on the Brew Better system, and now I'm proposing that on all your systems. If you want to have a self-contained, low-cost HMI type touch panel situation. Now, mind you, these other companies, yeah, they're going out to the field and they're all doing startup. That's the difference. They're going to the field and they're charging an enormous amount of money for startup. The reason why they're going out to the field and charging the startup is because they're bringing their own cable, their own communications cable, and they're resolving it. They've got the instrumentation required to minimize, which is the key word, not eliminate, minimize the effect, the VFD effect that's having on the probes and the interference. So it's always there. And again, I talked extensively to a control tech at the show, and I talked to another company that did a project in Phoenix, Arizona, where the control panel, I gave him the same specs on the control panel that I did for the Australian project. He quoted me $30,000 plus another 10 grand to go down there and do it. So I realized that, you know, it's extremely pricey, and this is something we want to eliminate. Minimizes our cost. So if we're gonna actually give them a plug and brew type system, we're gonna have to make that temperature control. We're gonna have to either go with the Honeywell type controllers, which eliminates the ability to mess around with that on the touch panel, or we're gonna have to go with DC motors and DC drives, and that's DC motors and DC drives throughout the entire system, and that's gonna make a rock solid system that's basically can plug into the wall into a 110 outlet and then run the entire brew house. Thank you very much.